Okay, in this video I'm having a look at the past paper for 2023 for the maths methods, and I'm looking at paper 1, which is the tech-free paper. It's starting with the multiple choice questions. So the first question that we're going to look at is question 1. Now it's got e to the power of ln x is equivalent to, and so this is one where we know if we're raising something to the power of ln x, raising e to the ln x, it's going to give us an answer of x. So it's one of our things that we know, and just one of our basic rules that we should know about our e to the power of x rules. Then we've got question 2, where we have f of x is equal to e to the 6 minus 2x. We want to determine the value of f dash 2. So we need to find f dash x for that. So if you need to, you can write that as e to the negative 2x plus 6, if that makes it a little bit easier, because you're bringing down that derivative of the x. So we're going to bring down the negative 2, and then we will have our e to the 6 minus 2x left over. That stays the same. Then we want to find out when we've got our x is equal to 2. So we've got f dash 2 is equal to negative 2 e to the 6 take 2 times 2. So we've got negative 2e to the 6 take 4, negative 2e to the 2 is our answer, and we look over here and that is our D, our answer there. Question 3, a bag contains 10 buttons of the same shape and size in different colours, 5 blue, 3 green, 2 red. If 3 buttons are randomly drawn from the bag, which probability can be calculated using the binomial distribution? So that's the key part there, the binomial. So for binomial, you have to have only 2 outcomes, success or failure, and you have to have the same probability each time and a set number of trials. So we've got our 3 buttons, so that's our set number of trials. We've got 3 different colours. So when we're looking at these options here, we need to look at ones that only have 2 outcomes there. The other thing is the probability needs to stay the same. So if we've got without replacement, they're automatically gone because the probability from one trial to the next is not going to stay the same. Then when looking at the 2 options here, we've got the probability of 3 green with replacement, or the probability of 2 green and 1 red with replacement. So a little bit of thought going behind there, going, well, if it's the 3 green, then I guess you're assuming your success is green and your failure is not green. If we've got 2 green and 1 red, then that's really not going to work for a binomial, and you would have to make a lot of assumptions as to how that was going to work with success and failure. So A is the answer there, assuming that you've got green is your success and not green is the failure, so that would be the blue and the red. For question 4, we've got the gradient of a function f of x is given by 20 over x cubed. So that is your derivative, and they're asking you to find f of x. So you need to find the integral of that. So you're going to do the integral of 20 on x cubed. Now, if you need to write that to make it a little bit easier for you to see what's happening, write it as x to the negative 3. So you're bringing that x cubed up the top there, and then when you're integrating, remember that you are adding 1 to the negative 3, so that'll be negative 3 plus 1 is negative 2. You're going to divide by the new power, and you've got the, and I won't put the box brackets because we're not doing a definite integral, I'll put my plus c there. So then I need to simplify that. So 20 divided by negative 2 is going to give me negative 10 x to the negative 2 plus c, and I'll look over here and I've got negative 10 over x squared. So I can write that as my negative 2 there is the same as negative 10 over x squared plus c, and there's my answer there of c. Question 5. So now we are doing a definite integral of 1 over 2x. So when we write that, we can write that as a half of the integral between 1 and 3 of 1 over x. So we've taken that half out the front. Then we know the integral of 1 on x is ln x. So we've got a half of ln x, and we want to look at that between 1 and 3. So then we're going to sub in the 1 and the 3 there. So we've got a half of, and we actually could leave that half right out the front makes it even easier. A half of ln of 3, take ln of 1. We know when we subtract, that means we have our divided by, so 3 over 1 there. So it's a half of ln 3. And then when we look over, that is our answer D. For question 6, a little bit of an unusual one here. So we've got substitutions for h are used to estimate the limit of a to the power of h minus 1 over h as h approaches 0. Which sequence is the most appropriate? So subbing into there. So I'm looking at the lines going, okay, well, if we're putting in the substitutions, we want to be approaching 0. So we want something that's going to 0. So automatically we can rule out D because that's just going up. C can go because it goes down to 0 and back up again. That's not really going to be helpful. B has negative, like it seems to be getting bigger further away. So A, I think, is the most appropriate because we are going from -4, -2, -1. We're getting closer and closer to 0 there. Question 7, we have got determine the mean of the continuous random variable with the probability density function of this. So when we're doing that, that's the one where we are going to find the integral of that function, but it's going to be x f of x. So we need to put an x in front of it there, which then becomes the integral of 1/8 x squared. Now we can take that 1/8 out the front, and then the integral of x squared is just going to be x cubed on 3, and we've got 1/8 of that, and we're looking between 0 and 4. So then we're going to sub in the 4, sub in the 0. When we sub in the 0, we're just going to get 0, because 0 cubed divided by 3 is still going to be 0. So we're subbing in the 4. So we're going to get 1/8 of 4 cubed over 3 there. So that gives us, when we do our 4 cubed, we get 64. And when we've got our 1/8 times the 3, that's on 24. Then we can simplify that. 64 over 24, we can divide each of them by 8. So we get 8 over 3 as our answer. And over here we can see that is D. Remembering we don't have calculators because it's tech free. Question 8. So question 8 requires you to know that rule where you've got, you're finding the confidence intervals. So where we have, if our margin of error is 3%, that's what we're plus or minusing. So we would have that p hat plus or minus rule. So we've got that the 3% is going to equal the 1.96, the square root of p outside of 1 take p over n. And then we're going to put in what we know. So we'll change the 3% to 0.03. We've got the 1.96. Now we've got our sample proportion is 0.6 outside of 1 minus 0.6 over n. And we're trying to get the n on its own. So 0.6 times, and then 1 minus 0.6 is going to be 0.4. When we do 0.6 times 0.4, we're going to get 0.24 over n. And you can start to see where some of these numbers are coming out that they're using in these options here. So first step, divide by the 1.96. And we're going to get that is equal to the square root of 0.24 on n. Then we're going to do this square both sides. So our 0.03 on 1.96 is going to be squared. That will give our 0.24 on n. And then when we're dividing by n, what we can do is make those two swap places. Your long way of doing that would be bring the n over and then divide by the 0.03 over 1.96 squared. I just like to say make them swap places. So we've got 0.24 over 0.03 on 1.96 squared, and that gives us the answer of B.